Hey geometry students, today we're going to be looking at lesson 3.1, and just to let you know, this chapter is going to go it's going to go fast because we actually are going to be skipping two sections out of this chapter. We're going to be skipping section 4 and 5, and so we'll only be doing sections 1, 2, 3, and then skip all the way to 6, and we're done. So like I said, it's going to go pretty fast. But in this lesson, 3.1, we're going to learn about different lines and angles. And here are our objectives. We're going to identify parallel, perpendicular, and skew lines. And those are our definitions also right there. And identify the angles formed by two lines and a transversal. We will look at what a transversal is and their corresponding lines. So let's get started. Okay, so here are four of our definitions in this section. We're going to be learning about parallel, perpendicular, and skew lines, and also something called parallel planes. We've seen parallel lines and perpendicular lines before, but parallel lines so far we have learned are two lines that never intersect each other, which is true, but we're extending our thinking here to this right here. Parallel lines are coplanar and do not intersect. If you remember what coplanar means, it means they lie in the same plane. So parallel lines, for example, AB and EF. AB right here and EF. They are in the same plane and yet they never intersect. So they are parallel lines. Okay, just real quick, I am going to do something. I realized that this letter is supposed to be a D instead of a W. So I'm going to fix that real quick. Okay, so now that's fixed. Let's look at perpendicular lines. So perpendicular lines, same definition as we learned before. They are intersecting lines that intersect at a 90-degree angle. So in this figure, wherever you see a right angle symbol, like this right here or this down here, those are lines that intersect at a 90-degree angle. So you have AB and AE. Well, AB and AE, yes, those are perpendicular lines. And then EG and GH. Those are perpendicular lines because it says so. Now, skew lines, this is the reason why our parallel lines definition changed just slightly to that they are coplanar and do not intersect. We didn't have this piece of our definition before. But in this lesson right here, we're learning about skew lines, and also these lines will never intersect. But another thing about skew lines is that they are not coplanar. So skew lines are not coplanar, and skew lines are not parallel, and they do not intersect. Well, if they're not parallel, they're never going to intersect. So that's kind of redundant there. But anyway, in this figure right here, an example is AB and EG. So AB here and EG right here. See how these two lines right here are not in the same plane. They're not both in this plane or in this plane right here or on the back side where AB intersects each of those planes. And EG, it's just they're not lying in the same exact plane like the EF and AB. They are in two different planes and they will never intersect each other. Let's look at another example of skew lines. Let's look at GH. GH, and let's pick something going up and down. That usually helps. Yes, BD. So those two are skew lines also. Now you can locate many pairs of these three types of lines in this figure here on your own. but we're going to move on to something called parallel planes. So parallel planes are planes that do not intersect. Just like our lines, our parallel lines, they do not intersect. In this figure, here are two planes that do not intersect, so therefore are parallel. So ABE, now remember, whenever we name planes, we only have to name 3 points in our plane. Okay, so ABE is this up here, ABE, so this top part of our box, and CDG, so CDG, now the bottom part of our box. Those two planes are parallel to one another. Now, let's see. Now, the left side and right side of this box would be also two planes that are parallel to one another. And then the front side and back side. So the EGF, that side of the box, and ACB, the back side of the box. They are two planes that will never intersect each other. So those are parallel planes. Now let's move on to some exercises. So in here, we're asked to identify the following. It says we're going to identify a pair of parallel segments. So here we've got symbols of parallel all over the place. See how these double parallel symbols are on here? All of the lines that have this double arrow are parallel to one another. And all of the ones that have this single arrow are parallel to one another. So if you name any pairs of those lines with each other that have this same amount of arrows on it, you have named parallel segments. Okay, so I'm going to go ahead and state a couple of those. Or I can just state a pair. That's what we're asked to do. Let's state a pair. So BF, now this is a segment, so put your segment notation over it. And it's parallel to EJ. Okay, let's do another pair of segments. How about BE is parallel to, well, it's parallel to a lot of things. BE, let's just say down here, FJ. Oops, not GJ. Okay, so there are a pair or two pairs of parallel segments. Now let's look at a pair of skew segments. Now remember, skew segments are not coplanar and they do not intersect. So let's start out with BF again and then find a line that is not coplanar and does not intersect. So BF, and let's see, let's highlight that, BF, and let's go to the back side of the box here to GH. Those two lines will never, or segments, they will never intersect each other and they are not coplanar. So those are my segments I'm going to use for this example. Okay, those are a pair of skew segments. Alright, let's look at a pair of perpendicular segments. Well, I only see one right angle symbol on this figure, so that's the only one we can actually assume is these two lines are intersecting at a right angle or 90 degrees. But we will learn later that actually all of these here are also right angles because of it being parallel lines. We'll learn that in the next section though. Let's concentrate on this one. So BF again is perpendicular to, that's that symbol there, means is perpendicular to this line here, FJ. Now let's name a pair of parallel planes. So let's see. Let's name the top of this cuboid here. That is parallel to this one here. So let's name those. So plane, what is that? BCD. There's many names for that plane. It's parallel to plane FGH. And there we go. We're done identifying these following relationships between lines and planes. All right, let's look at another one. Okay, we're asked to find pretty much the same thing as we were asked to find in the previous one. Now, this figure here, again, it tells you which lines are parallel and which ones are perpendicular by the symbols it draws on the figure. That's how it will always be. See how it has right angle markings here and here? It has parallel markings for every line that's parallel to each other. Over here too, these are parallel. Okay, so for identifying pairs of parallel segments, just identify them by stating the correct name. So let's start up here. Let's do this line right here, NK. And it's a segment that we're looking at. So NK is parallel to, let's see, ML. But it's also, you could have stated that it's also parallel to this line down here, SP. Okay, so we've gone a little bit further than we really wanted to, but still. Those are all segments that are parallel to one another. Now let's name a pair of skew segments. So, a pair of skew segments. Let's look at that segment NK again. Start out with it. And then identify a line that is skewed to the segment NK. Now, whenever I do something like this, lines that are kind of going left to right, then I want to find something that's going up and down. That's kind of how I identify skew lines. So any line that's going up and down that does not intersect with NK over there is skewed to NK. So either this line here, MR, or this line over here, LQ. So I'm just going to name one of those, MR. Now let's look at the next one. We are asked to find a pair of perpendicular segments. Like I said earlier, any one of these, or any two of these lines that intersect each other at a right angle, that's denoted on your figure, are perpendicular segments. So let's look at this one right here. The two lines that intersect at that right angle are NS, and it's perpendicular to SR. There you go. There's a pair of perpendicular segments. A pair of parallel planes. Okay, we've already got this line started. Let's look at this plane right here, the front side of this card stack, and name it. So plane, let's see, NMR. And that's parallel to, well, it's parallel to this back side, the card that is the 2 of spades. So plane, name that one. You can name it anything with any 3 of those 4 letters in any order that you want. I'm going to say KLP. Okay, and we are done with this one. Hopefully these 2 examples have given you a better idea of what parallel segments, skew segments, and perpendicular segments are, and also parallel planes. Let's look at identifying angle relationships. So here are some definitions of types of angles that we will come across, and where they come from is this right here, this example that I have for you. We have 2 lines that are in the same plane, and then there's this line going through it called a transversal, and that's where the definition comes from. So a transversal intersects 2 lines that are coplanar. All right, so we have these angles, these different types of angles, and the relationships that they have with each other. We're going to look at those. So corresponding angles, these types of angles lie on the same side. So in this figure, we have this side of the transversal. I'll call this the left side, and then this side of the transversal, which is the right side. Now, depending on your figure, you can angle it different, and it could be the bottom of the transversal and the top of the transversal. Just corresponding lines lie on the same side, okay? And then these 2 lines, or these 2 angles, are in the same position. So what I mean by position is, like, angle 1 and angle 5 are both on the tops, or on the above the 2 lines. So they're both on the same side, and they're both above their lines. They're the 2 lines that are in the same plane. Okay, so 1 and 5 are called corresponding angles. Well, another pair of corresponding angles, I would say, is 3 and 7, because they lie on the same side of the transversal, and they're in the same position as each other. They lie on the bottom side of each of those lines, R and S. Now, if you go to the other side of the transversal, you have corresponding lines on that side too, such as 2 and 6. Those are corresponding angles. And then also 4 and 8. Those are corresponding angles. Okay, I think that's the list of all corresponding angles there for that figure. Now let's look at alternate interior angles. Now these angles, they lie on opposite sides of the transversal line, and then they're on the interior, or they're in between your 2 lines. So I have labeled here that this is the interior, and this right here is the exterior. Okay, so these pairs of angles, alternate interior angles, like I said, alternate meaning not on the same side, they're on opposite sides. So they're opposite sides of the transversal, and they are on the interior. So 3 and 6 would be an example of that. And also another pair of alternate interior angles are 5 and 4. Those are going to be another pair. And that's it for alternate interior angles. That's the list. All right, let's look at alternate exterior. Again, Alternate meaning they lie on the opposite side of the transversal, but they are on the exterior. So where you see exterior, that is where they're going to lie. But remember, opposite side of the transversal, so over here and over here, like 1 and 8, or 7 and 2. Those two pairs I just named are both alternate exterior angles. Now we're going to look at something called same side interior angles, or as you may hear me call it, consecutive interior angles. Now consecutive means the same thing as same side. And like the name of it, it is on the same side of the transversal. So again, like corresponding angles, they lie on the same side. The same side interior angles lie on the same side. But here they are. And 3 and 5 is going to be a good example of this. It's listed right here. 3 and 5 are same side interior angles because they're on the interior and they're on the same side of the transversal. Now, another pair of same side interior or consecutive interior are 4 and 6 because they lie on the same side and are on the interior. So that there is all of our pairs of angles that are formed by a transversal. So let's look at each pair of angles and identify an example for each. Or we can identify all of them for each type of angle. Alright, so let's look at corresponding angles. Remember, corresponding angles, they lie on the same side of the transversal. So this right here, this line that goes through these two is our transversal. And remember, corresponding lines, they correspond to each other. They're in the same position. So like, let's circle it, like 1 and 5. Those are corresponding lines. So angle 1 and angle 5. Now there's many more of them on this figure we can identify, such as 4 and 8. Again, those are corresponding angles. So angle 4 and angle 8. Alright, now let's look at alternate interior angles. Remember, this right here in between our two lines, that's the interior. So those are the types of angles that we're going to be looking at. So it narrows it down to the 4, 3, 5, and 6. But it's on the opposite sides of that transversal here. So such as 4 and 6. That is what I would name as my alternate interior. 4 and 6. Angle 6. Or we can say 3 and 5. Okay, now let's look at alternate exterior angles. Let me find yet another color here. How about that one? Alternate exterior angles. Again, they are on the opposite side of the transversal, but they're on the exterior of our two lines. So a pair such as 2 and 8. Now, our consecutive interior or same side interior, they lie on the same side of our transversal and are on on the interior. So I'm going to name 3 and 6. And there we have it. We've named pairs, or given examples of each pair. Now this one is a little bit more tricky. We have 3 lines intersecting each other. However, any one of these 3 lines can be the transversal at any given point in time. It just depends on what angles we are looking at to describe or classify each pair. Okay, so let's do this. I'm going to fill out with this by, okay, if we look at angle 1 and angle 3, you can see those angle 1 and angle 3. Well, if we treat line L as the transversal, just think for a minute, what are angle 3 and 1 to each other? They lie on the same side of our transversal L, and they are one's on the interior like 3 and one's on the exterior like 1. So they're in the same position as each other. So same position on the same side of the transversal. Those are going to be corresponding. Oops. I can't draw my letters. There we go. Corresponding angles. Alright, now let's look at 2 and 6. Again, now 2 and 6. Now, comparing these 2 angles, line N, this line right here, is going to be our transversal. And see how 2 and 6 lie on opposite sides of that line? Well, that tells us it's going to be one of the alternate types of angles. So alternate interior or alternate exterior. Well, we can narrow it down because 2 and 6 do not lie on the outside of our lines L and M. They are on the inside. They're in the interior. So it's alternate interior angles. I'm just going to abbreviate it. Alternate interior angles. Now let's look at 4 and 6. 4 and 6, where are you? Right here and here. Now, again, our transversal line changed according to what angle we're looking at. So here our transversal is line M. And our angles 4 and 6, they are again on the opposite sides of that transversal. So again, you can narrow it down to alternate interior or alternate exterior. Well, look where these 2 angles lie. They are on the outside of N and they are on the outside of L. So alternate exterior is what fits here. Okay, so that's what I have for you for identifying angle relationships. Now let's look at this last slide. This last slide is what I'm going to tell you all to do on your own. And what I want you to do is name the pairs of angles that are listed here in 1, 2, and 3. And remember, answer these questions complete. It says name the pairs of corresponding angles. Now, I didn't say give an example of corresponding angles according to this figure here. I want all pairs of corresponding angles. So you're going to list 4 different pairs of angles for me for corresponding angles. And then again, 2, it says name pairs of alternate interior angles. And so name all pairs of alternate interior angles. There's going to be 2 pairs of angles on number 2. And then the last one here, name the pairs of consecutive interior angles. Again, there's going to be 2 pairs of angles for this one too. So answer these questions. I want to see them answered in the next class that we meet. So I'll see everybody later. Bye, everybody.